This is number 14 in our Chapter 3 test review on page 181, where we're asked to factor the expression completely. As always, we must look for a greatest common factor first. There is not one. So second, we look to see if it might be a special case. Well, it's a trinomial. The only special case that we have for trinomials is a perfect square trinomial. Obviously, it does not begin nor does it end with a perfect square. Therefore, this is a tricky one. We need to factor using our unfoiling method. So what we have to do is we have to take our leading term times our constant, and in this case we get negative 576. We need to find two numbers that when multiplied together they equal negative 576, but when added together they equal the middle term, which in this case is 55. This is trickier. 9 times 64 is equal to 576. If the 9 was negative, then when we add them, they would equal 55. Tricky one. So I'm going to break this middle term down into negative 9n plus 64n and bring down my remaining terms. So now we've broken this polynomial into an even number of parts. So we're going to group the first two and group the latter two and find the greatest common factor of each. So for the first two, what they have in common is 3n. If we divide out 3n, we'll be left with 8n minus 3. If it's factorable, then here in our second group, we'll have the same 8n minus 3. What was the greatest common factor? 8. Because 8 times 8n is 64n, and 8 times negative 3 is negative 24. Now, we have two terms. What do those two terms have in common? 8n minus 3. If we divide out that 8n minus 3, what do we have left over? 3n plus 8. If we FOIL, we of course, if we did it correctly, will end up with the polynomial that we began with, 24n squared plus 55n minus 24. And it does in fact work.